Welcome to Ranking. Today, we are going to the ocean. Not to a beach. Not to a coral reef. We are going to the actual ocean, the deep, pressurized, almost entirely unexplored body of water that covers 71% of our planet's surface and contains the most extreme environments on Earth. The ocean is home to the largest animals that have ever existed, mountain ranges larger than anything on land, rivers and lakes that exist underwater, and life forms so alien, they genuinely challenge our assumptions about what life needs to survive. We know more about the surface of Mars than we know about the deepest parts of our own planet. These are the facts about the ocean that will make you feel like you are living on a genuinely alien world, one you have never actually seen. Let's get into it. 95% of the ocean has never been seen by human eyes. 95% of the ocean has never been seen. The ocean covers about 361 million square kilometers of Earth's surface. It has an average depth of about 3,700 meters, making it an almost incomprehensibly large volume of water. Despite centuries of exploration, despite satellite technology, despite submarines and remotely operated vehicles, we have directly observed less than 5% of the ocean floor. The other 95%, an area vastly larger than all the continents combined, has never been seen by a human or a camera. The reason is extreme pressure. Water pressure increases by approximately 1 atmosphere every 10 meters of depth. At the bottom of the Mariana Trench, nearly 11,000 meters down, the pressure is over 1,000 atmospheres, the equivalent of the weight of 50 jumbo jets pressing down on every square meter. Building vehicles that can survive these conditions is extraordinarily difficult and expensive. The entire ocean floor has been mapped using sonar, sound waves, but sonar resolution is poor. Our maps of the ocean floor are less detailed than our maps of the surface of Mars, which we have photographed from orbit at high resolution. We have a better picture of distant planets than of the world beneath our own oceans. The Mariana Trench is deeper than Mount Everest is tall. The Mariana Trench and Mount Everest. Mount Everest is the tallest mountain on Earth, measuring 8,849 meters above sea level. The Challenger Deep, the lowest known point in the Mariana Trench, is approximately 10,935 meters below sea level. If you placed Mount Everest at the bottom of the Mariana Trench, there would still be over 2,000 meters of water above its summit, more than 2 kilometers of ocean above the top of the world's tallest mountain. The Mariana Trench is located in the western Pacific Ocean, near the Mariana Islands, and was formed by the subduction of one tectonic plate beneath another. It is not just deep, it is a dark, cold, crushingly pressurized environment where the temperature hovers just above freezing. Sunlight has never penetrated, and the pressure would instantly destroy any unprotected object. Only 3 descents by humans to the full depth of the Challenger Deep have ever been made. One in 1960 by Jacques Piccard and Don Walsh, one in 2012 by filmmaker James Cameron, and a series of dives beginning in 2019. We have visited the deepest point on Earth fewer times than humans have walked on the moon. The ocean produces more oxygen than the Amazon. The ocean produces more oxygen than the Amazon. The Amazon rainforest is often called the lungs of the Earth, a vast green engine that produces oxygen and absorbs carbon dioxide. It does. But the ocean produces more. Approximately 50 to 80% of the Earth's oxygen is produced by the ocean, primarily by microscopic organisms called phytoplankton, tiny plant-like creatures that live near the ocean surface and perform photosynthesis. A single genus, Prochlorococcus, may be responsible for 20% of all the oxygen on Earth. These organisms are so small that millions of them fit in a single teaspoon of seawater, and most people have never heard of them. When you breathe in, roughly 1 of every 2 oxygen molecules you inhale was produced by the ocean. The ocean is not just a habitat or a climate regulator. It is the primary factory for the atmosphere that makes complex life on Earth possible. This makes the health of the ocean a direct question of survival. Changes in ocean chemistry, temperature, and acidity that harm phytoplankton populations have consequences that extend directly to the air we breathe, in every country, at every altitude, regardless of how far from the water you live. There are rivers and lakes at the bottom of the ocean. Underwater rivers and lakes. The ocean floor contains bodies of liquid water that behave exactly like rivers and lakes, complete with shorelines, waves, and even waterfalls, despite being thousands of meters beneath the sea surface. These are called brine pools. They form when seawater seeps into thick deposits of ancient salt left behind by evaporated prehistoric oceans. The salt dissolves into the water, creating a brine, a liquid so dense and so salty that it does not mix with the surrounding seawater. It sits as a distinct body of liquid, with a visible surface, on the ocean floor. These brine pools are typically extremely low in oxygen and extremely high in salt, toxic to most forms of life. They kill most sea creatures that venture into them, which is why they have been called underwater lakes of death. Some are known to release methane, and they can even have small underwater waves moving across their surfaces. And yet, uniquely adapted microbial communities live in them. Extremophile bacteria thrive at their edges in conditions that kill everything else. These underwater lakes are one of many features of the ocean floor that challenge our expectations about what environments look like and who can live in them. Bioluminescence is the dominant form of communication in the deep ocean. Bioluminescence in the deep sea. Below about 200 meters depth, sunlight does not penetrate. The deep ocean is in permanent darkness, not dimness, not twilight, but complete and total black. In this environment, approximately 76% of deep-sea creatures produce their own light through a process called bioluminescence, a chemical reaction that generates light without heat. They use this light to hunt, to attract mates, to lure prey, and to communicate. The anglerfish, famous from Finding Nemo, uses a bioluminescent lure dangling from its head to attract prey in pitch darkness. Dinoflagellates, microscopic plankton, produce the famous blue glow sometimes seen in disturbed ocean water at night, creating glowing waves on beaches and sparkling wakes behind boats. Some squid can flash bioluminescent patterns across their bodies in milliseconds, like living display screens. The deep ocean, which we tend to imagine as silent and empty, is instead a dark environment pulsing with self-generated light, with creatures flashing, glowing, flickering, and shining in patterns as complex and varied as anything found in the daylit world above. Bioluminescence has evolved independently, at least 40 separate times in ocean life, suggesting it is such a useful adaptation that evolution discovered it over and over again. Sound travels 4 times faster underwater than in air. Sound travels faster in water. The speed of sound in air at sea level is approximately 343 meters per second. The speed of sound in seawater is approximately 1,480 meters per second, more than 4 times faster. This difference has profound practical consequences. The ocean contains a natural sound channel called the SOFAR channel, sound fixing and ranging, located at a depth of roughly 600 to 1,000 meters, where a combination of temperature and pressure causes sound waves to be trapped and channeled horizontally across vast distances. Sound entering the SOFAR channel can travel from one ocean to another, across entire ocean basins, losing very little energy along the way. Blue whales, sperm whales, and fin whales have been exploiting this natural waveguide for millions of years, communicating across thousands of kilometers. In 1960, an underwater explosion near Australia was detected by hydrophones on the other side of the world, demonstrating the channel's extraordinary range. During the Cold War, the U.S. Navy used the SOFAR channel to secretly track Soviet submarines in the Atlantic. The ocean is not silent, it is an acoustic superhighway, carrying the songs of whales and the sounds of earthquakes across distances that make radio transmission seem modest. The Pacific Ocean is larger than all land masses combined. The Pacific Ocean versus all land. The Pacific Ocean covers approximately 165 million square kilometers. The total land area of all 7 continents combined, every bit of land on Earth, from the Sahara Desert to Antarctica, is approximately 149 million square kilometers. The Pacific Ocean alone is larger than all the world's landmasses put together. It is not even particularly close. You could fit all of Earth's land inside the Pacific with room to spare. The Pacific is so large that it contains its own weather systems that affect climate patterns across the entire planet, including El Niño, the irregular warming of the central and eastern tropical Pacific that disrupts weather as far away as eastern Africa and northern Europe. The Pacific contains more than half of the Earth's ocean water by volume. It stretches from the Arctic in the north to the Antarctic in the south, and from the western coasts of the Americas to the eastern coasts of Asia and Australia. Its deepest point is deeper than any mountain on land is tall. The Pacific is not just a large body of water, it is the dominant feature of Earth's surface. A planet-spanning entity that contains more water than all other oceans combined. The mid-ocean ridge is the longest mountain range on Earth. The mid-ocean ridge. The longest mountain range on Earth is not the Andes, the Himalayas, or the Rockies. It is the mid-ocean ridge, a continuous underwater mountain chain that circles the entire globe like the seam on a tennis ball. The mid-ocean ridge stretches for approximately 65,000 kilometers, passing through the Atlantic Ocean, the Indian Ocean, and the Pacific Ocean. For comparison, the Andes, the longest above-water mountain range, is about 7,000 kilometers long. The mid-ocean ridge forms at the boundaries between tectonic plates, where plates are spreading apart, and new oceanic crust is being continuously created from magma rising from the Earth's mantle. This is the geological process that drives seafloor spreading and, ultimately, the movement of continents. The ridge contains thousands of active volcanoes. Along its length are hydrothermal vents, cracks in the seafloor where superheated water, rich in minerals, jets upward at temperatures exceeding 400 degrees Celsius. The vents don't exist in isolation. They are part of a vast geological system that is actively building new ocean floor every day, a process that has been continuously reshaping the planet for hundreds of millions of years. Hydrothermal vents support life without sunlight. Hydrothermal vents. Life without the sun. Life on Earth was assumed to depend, directly or indirectly, on sunlight. Plants use photosynthesis. Animals eat plants. Even deep-sea creatures that never see the sun subsist on dead organic matter, marine snow, that falls from the sunlit surface layers above. Then, in 1977, researchers diving in the submersible Alvin near the Galapagos Islands discovered something that upended this assumption entirely. Thriving ecosystems clustered around hydrothermal vents on the seafloor, 2,500 meters down, in complete darkness. These ecosystems are based not on photosynthesis but on chemosynthesis, bacteria that extract chemical energy from hydrogen sulfide and other minerals in the vent water. Giant tube worms up to 2 meters long, dense colonies of clams, shrimp, crabs, and fish, all living in an environment with no sunlight, extreme heat at the vent itself, and crushing pressure. The tube worms have no mouth, no gut, and no digestive system. They survive entirely through a symbiotic relationship with chemosynthetic bacteria living inside them. The discovery of vent ecosystems transformed astrobiology, the study of life beyond Earth. If life can thrive without sunlight at hydrothermal vents on Earth, then ocean worlds like Jupiter's moon Europa or Saturn's moon Enceladus, which likely have liquid water oceans beneath their icy surfaces, are suddenly much more interesting places to look for life. The dead zone in the Gulf of Mexico is growing dead zones. The Gulf of Mexico contains a hypoxic zone, a region of ocean so depleted of dissolved oxygen that most marine life cannot survive there. It forms each summer, driven primarily by agricultural runoff from the Mississippi River Basin, carrying nitrogen and phosphorus from fertilizers. These nutrients feed massive algae blooms in the Gulf. When the algae die and sink, bacteria decompose them, consuming oxygen in the process. The result is a zone of water that is technically alive, full of bacteria, but effectively dead for fish, crabs, shrimp, and any animal that requires oxygen. In recent decades, this zone has averaged an area of roughly 14,000 to 15,000 square kilometers, larger than the state of Connecticut. Dead zones exist worldwide. There are over 500 hypoxic zones in the world's oceans, affecting over 245,000 square kilometers of water. The Baltic Sea, the Black Sea, the Chesapeake Bay, and waters around heavily farmed coastlines in China, Europe, and South America all have significant hypoxic zones. They are directly caused by human activity, specifically industrial agriculture, and they are growing. Fish populations crash in these zones. Shellfish industries collapse. The ocean's capacity to absorb nutrients is not infinite, and we are exceeding it in multiple locations simultaneously. Icebergs are 90% underwater icebergs. The hidden mass. The phrase tip of the iceberg exists because icebergs are approximately 90% submerged below the waterline, with only about 10% visible above the surface. This is a consequence of the density difference between ice and seawater. Ice is about 917 kilograms per cubic meter. Seawater is about 1,025 kilograms per cubic meter. The ratio tells you that roughly 89 to 90% of ice by volume must be below the waterline to achieve buoyancy. The Titanic, which sank in 1912 after striking an iceberg, was destroyed not by the small visible portion of ice above the water, but by the massive hidden underwater shelf extending below and outward from the visible portion. The iceberg that sank the Titanic was estimated to be between 50 and 100 meters tall, meaning its underwater extent could have been 450 to 900 meters in depth. Modern iceberg tracking takes the underwater geometry very seriously, because the underwater portion can extend horizontally. The danger zone is much larger than the visible surface suggests. The largest icebergs in recorded history have been roughly the size of small countries. Iceberg B-15, which calved off the Ross Ice Shelf in Antarctica in 2000, was approximately 11,000 square kilometers, larger than Jamaica. The ocean absorbs about 30% of human CO2 emissions. The ocean absorbs carbon. The ocean is the world's largest carbon sink, a reservoir that absorbs and stores carbon dioxide from the atmosphere. Approximately 25 to 30% of the CO2 produced by human activity each year is absorbed by the ocean, slowing the pace of climate change compared to what it would otherwise be. This happens through two processes: physical dissolution, CO2 simply dissolving into cold ocean water at the surface, and biological uptake, phytoplankton absorbing CO2 during photosynthesis, dying, and sinking to the seafloor, carrying the carbon with them. However, this absorption is coming at a cost. When CO2 dissolves in seawater, it forms carbonic acid. As the ocean absorbs more CO2, it becomes more acidic, a process called ocean acidification. Since the Industrial Revolution, ocean surface pH has dropped by about 0.1 units, which represents a roughly 26% increase in acidity. For creatures that build shells or skeletons from calcium carbonate, oysters, clams, sea urchins, corals, more acidic water makes it harder to build and maintain their structures. Coral reefs, which support around 25% of all marine species, despite covering less than 1% of the ocean floor, are particularly vulnerable. The ocean's generosity in absorbing our carbon emissions is slowly acidifying itself in the process. A single cubic meter of ocean water contains millions of living organisms. Ocean water is teeming with life. Take 1 cubic meter of seawater from the surface of the ocean, about 1,000 liters. What does it contain? Approximately 1 million bacteria per milliliter, meaning 1 trillion bacteria in that cubic meter. Approximately 100,000 phytoplankton cells per liter. Zooplankton, tiny animals. Viruses at concentrations of 10 million per milliliter, meaning 10 trillion viruses per cubic meter. Fungi. Archaea. Protists. In a single cubic meter of ocean water, there is more life, in terms of number of individual organisms, than there are stars in the Milky Way galaxy. Most of this life is microscopic and invisible to the naked eye, but it is the foundation of everything. The ocean food chain begins with phytoplankton and bacteria. They are eaten by zooplankton. Zooplankton are eaten by small fish. Small fish are eaten by larger fish and marine mammals. Remove the microscopic life from the ocean and the entire structure collapses, whales, sharks, and tuna included. The ocean is not primarily a world of dramatic large animals. It is primarily a world of invisible microscopic organisms, so numerous that a bucket of seawater contains more living things than you can meaningfully imagine. The blue whale is the largest animal that has ever existed. The blue whale, largest in Earth's history. The blue whale is the largest animal that has ever lived on Earth. Not the largest animal alive today. The largest animal in the entire 4 billion year history of complex life. An adult blue whale can reach 30 meters in length and weigh up to 200 tons. A blue whale's heart weighs as much as a small car, approximately 180 kilograms. Its heartbeat is so slow and so loud it can be detected from 2 kilometers away. A blue whale's aorta, the largest blood vessel, is wide enough for a human to crawl through. The blue whale's tongue alone weighs as much as an elephant. Its call reaches 188 decibels, making it the loudest animal on Earth, louder than a jet engine. Despite their extraordinary size, blue whales eat almost exclusively krill, tiny shrimp-like creatures a few centimeters long. An adult blue whale eats approximately 4 tons of krill per day during feeding season. They were hunted to the brink of extinction during the 20th century, with over 360,000 killed between 1904 and 1967. International protection came in 1966. The current population is estimated at 10,000 to 25,000 individuals, less than 5% of their pre-whaling numbers. The largest animal to have ever existed is still endangered. Tsunamis are nearly invisible in the open ocean. Tsunamis in open water. A tsunami in the open ocean is almost impossible to detect from the surface. While a tsunami can travel at speeds of up to 900 kilometers per hour, as fast as a commercial aircraft, its wave height in deep ocean water is typically less than 1 meter, and its wavelength, the distance between wave crests, can be 200 kilometers or more. A ship at sea sitting on top of a tsunami would feel a very gentle rise and fall lasting several minutes, and would likely not notice anything unusual. The enormous destructive power of a tsunami manifests only when it approaches shallow coastal water. As the water depth decreases, the wave slows down, and its energy is compressed into a much shorter, much taller wave that can reach heights of 30 meters or more when it reaches shore. The 2011 Tohoku tsunami that struck Japan was generated by a magnitude 9.1 earthquake and produced waves up to 40 meters high, taller than a 12-story building in some coastal areas. It killed nearly 20,000 people and triggered the Fukushima nuclear disaster. That same tsunami, in the open Pacific just hours before landfall, was a gentle undulation barely detectable by instruments. The ocean concentrates its energy against the land. The ocean has its own waterfall. The world's largest waterfall is underwater. The largest waterfall on Earth by volume is underwater. It is located between Greenland and Iceland and is called the Denmark Strait Cataract. Cold, dense water flowing south from the Arctic meets the warmer, less dense Atlantic water, and plunges downward along the continental shelf. The drop is approximately 3,500 meters, more than 3 times the height of Angel Falls, the tallest above-water waterfall. The volume of water flowing over this underwater cataract is approximately 5 million cubic meters per second, approximately 2,000 times greater than the flow of Niagara Falls. This underwater waterfall is part of the global ocean conveyor belt, the thermohaline circulation, a planet-wide system of ocean currents driven by differences in water temperature and salinity. Cold, salty water is denser and sinks. Warm water rises and flows to replace it. This conveyor belt moves enormous amounts of heat around the planet, keeping northern Europe far warmer than it would otherwise be at its latitude, and playing a central role in global climate regulation. The massive underwater waterfall in the Denmark Strait is one of the engines driving this circulation, an invisible force shaping the climate of entire continents. There are more artifacts in the ocean than in all the world's museums. The ocean as history's archive. The world's museums contain approximately 650 million objects. The ocean floor contains an estimated 3 million shipwrecks, and that is just the ships. Below the surface of the world's oceans lie the remains of ancient coastal cities, now submerged by rising sea levels. Artifacts from trade routes that span millennia, cargo from vessels lost to storms, wars, and navigation failures across the entire span of human maritime history. The oldest known shipwreck, found in the Black Sea, dates to approximately 400 BC. Its preservation is extraordinary because the deep Black Sea is anoxic, lacking oxygen, which prevents the bacteria and organisms that normally decompose wood. Across the Mediterranean, archaeologists have found intact Greek and Roman trading vessels with their amphorae still stacked in the hold. In the Pacific, dozens of World War II warships rest on the ocean floor in conditions that have preserved them for over 80 years. In the Caribbean, colonial-era treasure ships wait in shallow reef systems. The ocean is the most comprehensive archive of human history that exists. We have recovered a tiny fraction of what is down there. The rest, cargo, weapons, manuscripts, tools, the everyday objects of past civilizations, is being slowly preserved or slowly destroyed by salt and pressure. Mostly unseen and unstudied, the ocean is estimated to contain 20 million tons of gold in the ocean. The ocean contains dissolved gold. Not in exploitable concentrations, but it is there. The best estimates suggest that the world's oceans contain approximately 20 million tons of gold, dissolved in the water. At current gold prices, That is worth in the range of $1.2 quadrillion. A number so large it is difficult to compare to anything meaningful. For reference, the total value of all goods and services produced by every country on Earth in a year is roughly $100 trillion. The oceanic gold reserve is approximately 12,000 times larger than annual global GDP. The problem is concentration. Ocean gold is dissolved at a concentration of roughly 13 parts per trillion, 13 atoms of gold for every trillion molecules of seawater. Extracting it would require processing volumes of water so enormous that the energy cost would far exceed the value of the gold recovered. Various inventors have proposed ocean gold extraction schemes over the past century. None have come close to working. Fritz Haber, who won a Nobel Prize for inventing the process to synthesize ammonia for fertilizer, spent years after World War I trying to extract ocean gold to pay Germany's war reparations debt. He failed. The gold will remain in the ocean, impossibly dilute, impossibly abundant. The ocean floor has active volcanoes. We have never seen volcanoes under the sea. Approximately 80% of all volcanic activity on Earth occurs underwater, mostly along the mid-ocean ridge. The ocean floor is the most volcanically active place on the planet. Most of this activity has never been directly observed. We infer the existence of underwater eruptions from temperature anomalies in the water, from chemical signatures in ocean water, from seismic data, and from the fresh lava found on remote sections of the ocean floor. On rare occasions, remotely operated vehicles have captured footage of active underwater eruptions, rivers of glowing lava flowing into cold seawater, building new rock at the rate of centimeters per year along spreading ridges, or dramatically faster at hotspot volcanoes. Hawaii itself is a chain of volcanic islands built by a hotspot beneath the Pacific Plate. The same hotspot is currently building a new undersea mountain south of the Big Island called Loihi, which is expected to break the ocean surface in approximately 10,000 to 100,000 years. Volcanoes are not just a feature of land. They are the dominant geological process shaping the ocean floor, and most of that shaping happens in complete darkness, under conditions of crushing pressure, entirely unseen by any human observer. Thank you for watching. The ocean is not just a large body of water surrounding the land we live on. It is the dominant feature of our planet, the engine of our climate, the origin of our oxygen, and the home of most of the life that has ever existed. We have barely begun to understand it. If this video made the ocean feel genuinely alien to you, that's because it is. Alien, unexplored, vast beyond comprehension, and right here on Earth. Subscribe for more, and we will see you in the next video.